Now that you have a local Git repository, we're going to look at how we can take that code and push it up to a third-party service called GitHub. GitHub is going to let us host our Git repositories remotely, so if our machine ever crashes, we can get our code back, and it also has great collaboration tools. So we can open source a project, letting others use our code, or we can keep it private, so only people we choose to collaborate with can see the source code. Now, in order to actually communicate between our machine and GitHub, we're going to have to create something called an SSH key. SSH keys were designed to securely communicate between two computers. In this case, it's going to be our machine and the GitHub server. This is going to let us confirm that GitHub is who they say they are, and it's going to let GitHub confirm that we indeed have access to the code we're trying to alter. This is all going to be done with SSH keys, and we're going to create them first, then we'll configure them, and finally we'll push our code up to GitHub. The process of setting up SSH keys can be a real burden. This is one of those videos I have in most of my courses, and it often gets the most questions because there's really small room for error. If you type any of the commands wrong, things are just not going to work as expected. So if you pay attention closely to any video, let it be this one. Now, if you're on Windows, you're going to need to do everything I do in this video from git bash as opposed to the regular command prompt, because we're going to be using some commands that just are not available on Windows. They are, however, available on Linux and Mac, so if you're using either of those operating systems, you can continue using the terminal you've been using throughout the course. Before we dive into the commands, I want to show you a quick guide that exists online in case you get stuck or you have any questions. You can Google GitHub SSH keys, and this is going to link you to an article called Generating an SSH Key. And once you're here, you'll be able to click this SSH breadcrumb, and this is going to bring you back to all of their articles on SSH keys. These four right here, the nested four, are the ones we're going to be focusing on. Checking if we have a key, generating a new key, adding the key to GitHub, and finally testing that everything worked as expected. If you run into any problems along any of these steps, you can always click the guide for that step, and you can pick the operating system you're using so you can see the appropriate commands for that OS. Now that you know this exists, let's go ahead and do it together. The first command we're going to run from the terminal is going to check if we have an existing SSH key. Now, if you don't, that's fine. We're going to go ahead and create one. If you do, or you're not sure you do, you can run the following command to confirm whether or not you have one. ls with the AL flag. This is going to print all of the files in a given directory, and the directory where SSH keys are stored by default on your machine is going to be at the user directory, which you can use tilde as a shortcut for, /.ssh. When you run the command, you're going to see all of the contents inside of that SSH directory. In this case, I've deleted all of my SSH keys, so I have nothing inside of my directory. I just have paths for the current directory and the previous one. Now that we have this in place and we've confirmed we don't have a key, we can go ahead and generate one. If you do already have a key, a file like ID_RSA, you can go ahead and skip the process of generating the key. To make a key, we're going to use the SSH-keygen command. Now the SSH-keygen with an N command takes 3 arguments. We're going to pass in T, setting it equal to RSA. We're going to pass in B, which is for bytes, setting that equal to 4096. Make sure to match these arguments exactly, and we're going to be setting a capital C flag, which is going to get set equal to your email. Now, the scope of what's actually happening behind the scenes is not part of this course. SSH keys and setting up security, that could be an entire course in and of itself. We're going to be using this command to simplify the entire process. Right here, I'm going to type in my email, andrewjosephmead@gmail.com. Perfect. Now I can go ahead and hit enter, which is going to generate 2 new files in our SSH folder. When you run this command, you're going to get greeted with a few steps. I want you to use the default for all of them. Here they want to ask you if you want to customize the file name. I do not recommend doing that. You can just hit enter. Next up, they ask you for a passphrase, which we're not going to use. I'm going to hit enter for no passphrase. Then I need to confirm the passphrase, so I'll just hit enter again. And right here, we get a little message that our SSH key was properly created and that it was indeed saved in our folder. You can see that right here. With this in place, I can now cycle back through my previous commands running that ls command, and what do I get? I get ID_RSA, and I get the ID_RSA.pub file. The ID_RSA file contains the private key. This is the key you should never give to anyone. It lives on your machine and your machine only. The .pub file, that is the public file. This one is the one you're going to give to third-party services like GitHub or Heroku, which we'll be doing in the next several videos. Now that our keys are generated, the last thing we need to do is start up the SSH agent and add this key so it knows that it exists. We're going to do this by running two commands. First up, we're going to run eval. Then we're going to open some quotes. Inside of here, we'll use the $sign and open and close some parentheses, just like this. And inside of our parentheses, we're going to type SSH hyphen agent space with the S flag. This is going to start up the SSH agent program, and it's also going to print the process ID to confirm it is indeed running. And right here, we get agent PID 16547. Your process ID is obviously going to be different. As long as you get something back like this, you are good to go. Next up, we have to tell the SSH agent where this file lives. We're going to do that using SSH-add. This takes the path to our private key file, which we have in the user directory /.sh/ID_RSA. When I run this, I should get a message like identity added. This means that the local machine now knows about this public-private key pair, and it'll try to use these credentials when it communicates with a third-party service like GitHub. Now that we have this in place, we are ready to configure GitHub. We're going to make an account, set it up, and then we'll come back here and test that things are working as expected. And now let's head into the browser and go to github.com. Here we'll be able to log into our existing account or create a new one. If you need a new one, fill out this form. If you have an existing one, go ahead and sign in above. Take a moment to pause the video until you see the screen that I see here. This is your GitHub dashboard. When you're done, go ahead and click play. All right, I'm going to assume that you're seeing your dashboard. From here, we're going to navigate into the settings over here by the profile picture, go down to settings, and in there, we're going to go to the SSH page, which is available under SSH and GPG keys. From here, we can add that public key, letting GitHub know that we want to communicate using SSH. I'm going to add the new SSH key, and you need to do two things. One, give it a name, and the name can be anything you like. I usually use one that uniquely identifies my computer since I have a couple. I'm going to use MacBook Pro, just like this. Next up, we need to grab the contents of that ID_RSA pub file. That contains the information that GitHub needs in order to securely communicate between our machine and their machines. We can grab this using a few different methods. Over in the browser, we have that adding a new SSH key to your GitHub account article. This contains a command you can use to copy the contents of that file to your clipboard from right inside of the terminal. Now, obviously, it is different for Mac, Windows, and Linux. So go ahead and run the command for your operating system. You can also go ahead and open it up with a regular text editor and copy the contents of the file. It doesn't matter how you do it. All that matters is you do. I'm going to use the pb copy command, which is available only on OS X. I'm going to move into the terminal and I'm going to run it. This copies the contents of the file to the clipboard. Now I can move back into GitHub, click the text area, and paste it in. Take a moment to copy the contents of ID_RSA pub, paste it into the field. It should start with SSH-RSA, and it should end with that email you used. Once you're done, go ahead and click Add SSH. Take a moment to pause the video, knock that out, and when you're done, click play. All right, I'm going to assume at this point you have that SSH key added to GitHub. Now we can go ahead and test that things are working by running one command from the terminal. Once again, this command can be executed from anywhere on your machine. You don't need to be in your project folder to do this. We're going to use SSH, which tries to make a connection. We're going to use the T flag followed by the URL we want to connect to, git@github.com. This is going to test our connection. It's going to make sure that the SSH keys are properly set up and we can securely communicate with GitHub. When I run the command, I get a message saying that the authenticity of the host, github.com, can't be established. We know that we want to communicate with github.com. We're expecting that communication to happen, so we can go ahead and hit yes. From here, we get a message from the GitHub servers. Hi, Andrew J. Mead, which is my username. You should see your username here. We've successfully authenticated, but GitHub does not provide shell access. If you are seeing this message, then you are done. You're ready to create your first repository and push your code up. Now, if you're not seeing this message, something went wrong along the way. Maybe the SSH key wasn't generated correctly or it's not getting recognized by GitHub. Go ahead and open a question in the Q&A for this lecture. I would be happy to debug. I know this can be a real burden. It's pretty tricky to set up. If you're seeing this message, what we're going to do is move into GitHub, go back to the home page, and we're going to create a new repository. Right here, we have our new repository button. All we need to do is give it a name. I'm going to call this one node-course2 web server. Once you have a name, you could give it an optional description, and you can pick whether you want to go with a public or private repository. Now, private repositories do put you on a $7 plan. I do recommend that if you're creating projects with other companies. In this case, though, we're creating pretty simple projects, and it doesn't really matter if someone else finds the code. So I'm going to go ahead and use a public repository by clicking that option. Once you have those two things filled out, you can click Create Repository, and you're going to get brought to your repository page. And it's giving you a little setup because currently there is no code to view, so it's giving you a few instructions depending on which situation you're in. The first one is for creating a new repository. We don't need that. And the last one is for importing our code from some other URL, which we're not going to do. What we have is an existing repository, and we want to push it from the command line. We're going to run these two commands from inside of our project. The first one adds a new remote to our Git repository. Remotes let Git know which third-party URLs you want to sync up with. Maybe I want to push my code to GitHub to communicate with my coworkers. Maybe I also want to be able to push up to Heroku to deploy my app. That means you would want two remotes. In our case, we're just going to add one. So I'm going to copy this URL, move into the terminal, paste it, and hit enter. Now that we have our Git remote added, we can go ahead and run that second command. This second command, which we'll be using extensively throughout the course, is going to take our code and push it up to GitHub. In the terminal, we can copy and paste the code, run the command, and right here we can see everything went great. We were able to successfully write all of our data up to GitHub. And if we go back into the browser and refresh the page, we're no longer going to see those setup instructions. Instead, we're going to see our repository, kind of like a tree view. Here I can see we have our server.js file, which is great. I don't see the log file or node modules, which is good because we ignored that. I have my public directory. Everything works really, really well. We also have issue tracking, pull requests. You can create a wiki, which lets you set up instructions for your repository. There's a lot of really great features that GitHub has to offer. There's entire courses dedicated to using GitHub, so I'd recommend checking one of those out. We're going to be using just the very basic features. Over here, you can see we have one commit. And if you click that one commit button, you can actually go to the commit page. And here we see the initial commit message that we typed when we made that commit. This is going to let us keep track of all of our code, revert if we make unwanted changes, and manage our repository. Now that we have our code pushed up, we are done. In the next video, we're going to look at how we can communicate with Heroku to deploy our code. Then after that, we'll look at some real-world workflows for creating new commits, pushing to GitHub, and deploying to Heroku. By the end of this section, you'll be a master at the process, so fear not. As long as you're able to see your code here, then you are all set up. You'll never need to touch those SSH keys again. Stay tuned. I will see you next time.